Dear colleagues, I am very glad to meet you at the conference. The war can't stop our enthusiasm to increase the environment and indoor air quality using the most natural approach, biotechnology that connect or replace artificial objects with living nature to solve multiple environmental, technical and social tasks in each one, which isn't possible by engineering systems themselves. There are outdoor and indoor green structures connecting building structures with plants, indoor greening, including passive and active phytoremediation systems, greened fences or hedges, connecting or replacing fences with plants, and rain gardens, replacing sewage. Most of the solutions are found in ancient times, possibly before writing, and the logical continuation is connecting plants with engineering systems, especially microclimate ones. Let me introduce the authors of the work. Tetiana Tkachenko, a doctor habilitatus, professor, head of the Department of Environmental Protection Technologies and Labor Safety at Kyiv National University of Construction and Architecture, a member of the National Technical Committee for Standardization TC82, a principal investigator of the work. I am Viktor Mileikovskyi, doctor habilitatus, professor of the Heat Gas Supply and Ventilation Department, a responsible executor of the work who takes part in creating the methods and performing thermotechnical and gas exchange research of green structures and also the development of connection of them with ventilation systems. Viktoriia, Konovaliuk, philosophy doctor, associate professor and associate professor of the same department, take part in the research in the same direction, especially in regions with mining. Maryna, Kravchenko, philosophy doctor, associate professor and associate professor with the Department of Environmental Protection Technologies and Labor Safety, research the environmental impact of green structures. Ihor, Satin, philosophy doctor, head of the Department of Mechanization of Sanitary Cleaning, Improvement and Landscaping of Cities, Scientific Research and Design Technological Institute of Urban Economy, researches waste treatment and environmental pollution. The main problem of modern dense building and high-intensive traffic is the negative influence on the environment, which causes a decrease in the outdoor air quality. This air will be taken by inflow ventilation. After cleaning from dust but not from other pollutants, it will be supplied to rooms, decreasing indoor air quality. In rooms, the air is polluted by furniture, building, finishing materials, equipment, etc., and it pollutes the environment after releasing by exhaust ventilation. In industrial regions or around traffic-jammed highways, outdoor air is too polluted to use for ventilation. In this work, a solution of the problem will be found. Indoor phytoremediation systems are the prospective biotechnology to increase air quality. Thus, they will be analyzed to use them as a prototype. As the main problem is carbon dioxide exchange, the test results of it should be discussed. Based on the result of analysis, a new PHYTOFILTER is proposed. Ways to decrease the energy demand for plant illumination should be also offered. Plants are the most natural promising beings for increasing outdoor and indoor air quality. Phytoremediation systems are the prospective biotechnology to increase air quality. Nevertheless, they operate independently of the biorhythm of plants, causing secondary pollution by carbon dioxide. Round the clock, they can humidify and clean air from volatile compounds, dust particles, etc., and release useful volatile phytoorganic compounds, including odorants and phytoncides. The last ones reduce pathogenic bacteria and viruses. Plants absorb carbon dioxide and release oxygen, but photosynthesis has a biorhythm. Most plants release oxygen during the daytime, except cressulicin acid metabolism CAM, which does it at night. The last plants originated from regions with very hot and dry conditions. The metabolism operates by closing stomata to save water and storing energy during illumination time. When the illumination is missing, the foliage uses the stored energy to perform gas exchange. The process of energy storage and using energy causes exergy destruction, which decreases the energy efficiency and requires more biomass for the same result. Brazing operates around the clock in all plants, consuming oxygen and releasing carbon dioxide. This causes secondary air pollution in breathing only time. Let us analyze the result of testing Egalenema Robellini by Intel House on 11 April 2015. The plant and urban weather station NetAtmo were put into a black and clear packet. In the black and packet, the concentration of carbon dioxide during 40 minutes rises from 796 to 2,311 parts per million. In a clear packet in sunlight, the concentration falls from 1,060 to 315 parts per million. From 6 past 4 post-meridian, the concentration starts increasing up to 1,572 parts per million at 6 to 7 anti-meridian. In the morning, the concentration falls to 263 parts per million. The research gives the idea to split a PHYTOFILTER operation. Active photosynthesis should be performed in supplier and breathing only in exhaust air to decrease outdoor air pollution. It requires a special design of PHYTOFILTERs. We propose a design of PHYTOFILTER model for inlet exhaust ventilation. The PHYTOFILTER has spaces 3 with plants and valve system 4. Controller 6 opens valves 4 to pass inlet air through one of the spaces, 3 with oxygen release, and host 1 through other spaces, 3. Controller 6 turn on illumination 5 only in the first space 3. When the plants in the first space will turn to breath only, controller 6 switches flows and illumination to another space 3. The model solves both internal and external tasks. It isn't only prepared high-quality inlet air but cleanses host air from indoor pollutants, which can act in the outdoor environment, especially in dense built districts. To avoid additional pollution due to energy consumption for illumination, we can use different approaches. Using natural illumination through clear walls of the model requires the combination of CAM and other plants, using natural illumination only for daily operated space 3, or proper installation it after an air handling unit. Installing the model after an air handling unit with the heater 4, cooler 5 and reheater 6 almost removes additional energy consumption. The heat from illumination decreases the need for energy for heating in the heating period and reheating in the cooling period. For this, we should use specially designed 3-dimensional adapter 10 to properly direct air flows. The valves usually installed on the exit of the air handling unit can be installed after the PHYTOFILTER and the second 3D adapter 10. Conclusions. Indoor pollutants are dangerous for people in buildings and pollute the environment, especially in dense built districts. Plants are promising beings for the solution of both problems, but we should take into account the biorhythm of photosynthesis. The proposed PHYTOFILTER design can pass inlet air through plants that absorb carbon dioxide and release oxygen, and also pass outlet air through breathing only ones, which ensure maximum inlet air quality and cleans outdoor air. The proposed installation and plant assortment give low energy consumption and high effectiveness. Thank you for your attention. Let us invite you for collaboration. The main directions and contacts are on the screen.